Alright, let's catch up with where we left off from last videos. So suppose that you want to graph this slope point or point slope form. First, step one is you need to identify the x1 and y1, which is the points that the line passes through. So x1 would be equal to 2 and y1 would be equal to 1. And you have the slope, which is 2. Now, the next step is you identify the point, you plot the point on the graph, the OXY, right? Your coordinates. So here, OXY here. Now, what happens is that you have x equal to 2, y equal to 1, so this is your first point. Now, you have slope equal to 2, which means what? Slope rise over run. So in this case, from the point here, you would rise 2, which is, let's say 2, 1, 2, and then you move to the right 1 unit, so that would be over here. So and then you just connect the two lines here. So okay, and voila. So you have y minus 1 equal to 2 times x minus 2. Alright, so another topic that I want to talk to you about is has to do with the application of linear functions. So in your science classes, so a linear function has a lot of application, especially in science. In physics, chemistry, biology, or any type of experimental, experimental science that will produce data from your experiments. So let's say that you have in a scientific experiment, you would have and this is just a quick review of the scientific process. You would go through what we call a hypothesis. You make a hypothesis, and then so observations, research, and then you make a hypothesis, and then you design your experiment. In your experiment, you need to think about what we call the independent variable, and dependent variable, right? Dependent variable. Now, there's another thing which is a control. Your control to make sure that your results are interpreted correctly. But I just want to focus on these two variables here, which is independent and dependent variable. So mathematically, independent variable would be your input, okay, your input, and your dependent variable would be the output. So input would x, output would be y. So this is actually a very good example of the definition of function. So function is like a machine or a box, a mysterious box here. We have a function, okay, the box function, and then we have we feed in with our information. So let's say this is our input, okay, and then through the box here, through a machine or factory, it will yield or release what we call the output, our product, okay, the product of our function. So to think it scientifically, we would see that let's say that you want to examine the effect of a type of fertilizer on the growth, the process of plant or trees. So what happens is that we want to find out, so let's say the amount of water or the amount of fertilizer, okay, so different concentration. So different concentration of fertilizer, okay, and then you want to manipulate that, okay, you want to manipulate the different concentration of fertilizers, and you want to see how height, okay, the height of the plants, number of leaves. So for example, so again, the height and number of leaves are dependent on what we call the manipulated variables here. So that's why the input has also the name independent, okay, or manipulated variable. And then here the output is called dependent variable. Okay, so in class I already talked to you about this already, so this is just a quick review. Now, so why do I talk about this? The reason why I talk about this is because we, when we do experiment, we sometimes have what we call table values. So let's say data. We have data. Okay, so let's say the data like this. Okay, and now let's switch back to what we call the mathematics side, because we will explore this later in later chapters. But let's just say that you want to graph. Let's say that you want to graph this function y equal to 2x plus let's say 2x plus 1. Okay, so if you didn't know about the other way, the quicker way to graph this function, using the y-intercept and then the slope, then the typical step would be you make a table of values, so x here and y here. Okay, and then you pick, let's say, several points. So let's say that I for the purpose of illustration, I would use, let's say, 0, 1, 2, 3, 4. Usually, again, we only need 2 points. 2 points are enough to graph a linear function. But for the interest of purpose of illustration, I'm going to write that have. So for example, so x here, you just input the x into the value of x here. So then you have 2 times 0 plus 1 equal to 1. 2 times 1 plus 1 equal to 3. Right? 2 times 2 plus 1 equal to 5. 2 times 3 plus 1 equal to 7. And then 2 times 4 plus 1 equal to 9. Okay, and then you just graph this. Now what happened if, so we know that this is a linear function already, so that we know that this is linear function already, and then we have this graph. Now have this table of value. Now what happens if we don't, what happens if we are given a table? And I'm going to copy exactly the same here. So let's say I have x and I have y here, okay, a table, and imagine that you don't know this, okay, imagine that you're not given this, imagine that you're not given this. So let's just say I have 0, 1, 2, 3, 4, 1, 3, 5, 7, and 9, okay, and they ask what kind of relationship is that, okay, so what kind of relationship is that? Is this, okay? So oh duh, I mean, like, we just finished linear function chapter, so it's either linear or nonlinear, okay? But later on throughout the semester you will learn different types of relationships, for example quadratic, exponential, polynomial, things like that. So the matter will complicate. But to focus on this one, so let's say that we have this, you're given this data table, and then they ask what kind of relationship is that? Is it linear or nonlinear? Now how do we solve this problem? So it's all about the slope, okay? It's all about the slope here. So let's say that if you calculate the slope, okay? So let's say that you make the difference, you find the difference between the two values in x and in y, okay? So here in this case, let's say that I have delta x and I make another column, and this one is delta y. So I use the value, I use this value minus the value before it. So for example, 1 minus 0 is 1. So the first difference is 1. The same thing, 2 minus 1 is 1. Okay, 3 minus 1 is 1. 3 minus 2 is 1. 4 minus 3 is 1. Okay, so the difference between the x values is 1. Now I'm going to make the same. I'm going to make the same with y. So 3 minus 1 is 2. So the difference 2. 5 minus 3 is 2 again. 7 minus 5 is 2 again. 9 minus 7 is 2 again. Okay, so what happened is that we want to find out delta y divided delta x, the ratio. Okay, so this one, the first pair is 2 divided by 1. 2 divided by 1 again. Again, 2 divided by 1, 2 divided by 1. So actually, these are equal. Okay, they are equal to each other, and it's constant. So what happened is that this, for this alone, we can conclude that this is a linear relation. Okay, this is a linear relation. Now, what happens if you are asked to write the equation for that? So here, 2 here is actually our slope. Why? Because this is the definition, based on the definition here. Delta y divided delta x equal to 2. So this is the slope. So you know slope already, it's 2. And then what you need is to find the intercept. Okay, there are two ways of doing this. Now, one way is that you know that this is, so y-intercept is when x equal to 0. So in this case, x equal to 0, y equal to 1. So in this case, my x-intercept is 1. So b equal to 1. Alright, so my equation will be y equal to 2x plus 1. Now, can I do it differently? Yes, of course. You know, you're more than welcome to do it in the other way. So another way of doing this is that you use point slope form. So for example, you have slope equal to 2 already, and you just choose one random pair. So for example, I choose 3 and 7. So I choose x1 equal to 3, y1 equal to 7 here. So my point slope point equation would be y minus y1 equal to m times x minus x1. So y minus 7 equal to m, which is 2, times x minus 3. So I just have to simplify. So 2x minus 6, y equal to 2x, and I plus 7 on both sides, so that will be y equal to 2x plus 1. Voila! So we have two approaches, but the same result.